guys, this is the notes for chapter 8.1 about geometric mean. So let's figure out what geometric mean means. The geometric mean of two positive numbers, a and b, is the number x such that 8 divided by x is equal to x divided by a. So x squared is equal to ab, or in other words, x is equal to the square root of ab. So this is our formula here. So let's go ahead and use that formula for example 1. It says find the geometric mean between 8 and 10. So remember, the formula is x equals the square root of ab. So that means x is equal to the square root of 8 times 10. Okay? Well, x is equal to the square root of 8 times 10, which is 80. And if you guys remember how to do the factor tree, we can simplify this into a proper radical, which would be 4 square roots of 5, or you could just type it into the calculator and get the decimal answer, which is about 8.9. Okay, and that's our answer. Let's go ahead and look at this theorem. So we have, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles form a similar to the original triangle and to each other. So we're going to use that to solve example 2. So it says, write a similarity statement identifying the 3 similar right triangles in the figure. So we're going to separate the triangle into 2 triangles along the altitude. Then sketch the 3 triangles, reorientating the smaller ones so that their corresponding angles and sides are in the same position as the original triangle. So the first triangle we have is this little tiny one right here, which is FJG. The next triangle we have is this red one right here, which is JHG. And then we have the total triangle, which is HGF. So these are all the similar triangles that were in that diagram. So then by theorem 8.1, the one that we just talked about, all these triangles are similar. So triangle FJG is similar to triangle GJH is similar to triangle FGH. Okay. Let's look at these theorems here. So we have the geometric mean altitude theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into 2 segments. The length of this altitude is the geometric mean between the lengths of the 2 segments. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into 2 segments. The length of a leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So we're going to use these 2 theorems to solve example 3. Okay, so in example 3, it wants us to find x, y, and z. So since x is the measure of the altitude drawn to the hypotenuse of the right triangle JKL, x is a geometric mean of the length of the 2 segments that make up the hypotenuse JM and MX. So we can write x equal to the square root of JM times MK using that formula. So x is equal to the square root of 5 times 20, which x is equal to the square root of 100, which is 10. So that is our answer. Now let's find y. Since y is the measure of leg JL, y is the geometric mean of JM. So we're going to say y is equal to JM times JK. So y is equal to the square root of 5 times 20 plus 5. So y is equal to the square root of 125, or approximately 11.2. Lastly, let's find z. Z is the measure of leg KL, so z is the geometric mean of MK. So we're going to do square root of MK times JK, which is equal to the square root of 20 times 20 plus 5, which is equal to the square root of 500, or about 22.4. So that's our answer. Okay, let's look at the next example. Zach wants to order a banner that will hang outside the side of his high school baseball stadium grandstand and reach the ground. To find his height, To find this height, he uses a cardboard square to line up to the top and bottom of the grandstand. He measures his distance from the grandstand from the ground to his eye level. Find the height of the grandstand to the nearest foot. So what we need to do is find the geometric mean using the altitude theorem. So we know that 10.5 is equal to the square root of 5.75 times x, because 10.5 is the altitude, which means it's the geometric mean. So by simplifying this, we can square both sides to get rid of that radical. So we have 110.25 is equal to 5.75x, divide by 5.75, and we get x is equal to 19.17. The height of the grandstand is the total length of the hypotenuse and the measure we just found. Well, the hypotenuse is 5.75. So the total height equals 5.75 plus 19.17, or in other words, about 25 feet. So that was rounded. And that concludes 8.1.